Hi, I'm Phil from Simply Rhino, and in this video I'm going to continue with our engine cover model. First, I'm going to take a look at creating this scoop on the main engine surface. There are two main considerations here. First, we need to maintain a seamless continuity between the main surface and the lead-in to the duct. Second, we need to control these edge blends so that they transition from a relatively straightforward edge blend condition and then run into the main engine cover surface. These are both fairly common problems in 3D modeling, even though the specific context might be different. Once we have the scoop completed, we'll then take a look at mirroring the two halves of the engine cover and then creating the final center blend. Finally, we'll make sure that everything is ready to export into SolidWorks. This is the result we obtained from the modeling we covered in the last video exercise. Now, to start to add the duct detail into this top surface, first of all I'm going to extract the top surface, the main top surface here, and I'm going to hide the rest of the geometry. I then need to add some curves to describe the sharp boundary of the duct area. These can be either curves that you draw and then project onto the surface, or in this case they're actually created from isocurves. The advantage in this case of using isocurves to create the boundary shape of the duct is that the shape that's created will be very close to the overall shape of the surface. So to create these curves, I went to Curve, Curve from Object, and Extract Isocurve, and Toggle to produce curves in the other direction. And then once I have these curves, I can trim them up with each other and join them. We need to make sure by just checking in object properties that the curves, when they're joined, produce a closed curve. Once we know that's the case, we can then go ahead and split our main surface with this closed curve. And I'm just going to hide the curve now. Now, of course, because these two surfaces are essentially derived from the same parent surface, then if we go to our Analyze and Surface and Zebra tools, then of course the area that we've trimmed out will be completely curvature continuous with the surrounding area. And the idea here is that we're going to leave the front edge of this surface as it is and adjust the rear edge of the surface to create the scoop. And the fact that we don't change the front of the surface means, of course, that it's going to be curvature continuous with our existing surface. Now, the first thing that we need to consider here is if we look at the control points for our small trimmed surface, they actually describe the overall larger surface, because when you trim a surface you don't actually change the control point structure. What we can do to make our control points here more manageable and relate more closely to our trimmed surface is to select the surface and run a command from Surface Edit Tools called Shrink Trimmed Surface. What this command does is that it reapproximates a new surface that has the same shape in U and V, it has the same number of control points and the same degree in U and V. The idea being that now our control points are relative to our smaller surface, but when we analyze the curvature of this with our Zebra tools, we'll see that our surface hasn't changed in terms of its shape, and so our two surfaces are still completely curvature continuous. If we take a look at the control points on our newly shrunk surface, what we know is that these first 3 rows of control points need to remain exactly where they are in order for us to maintain the continuity at the leading edge of the scoop or duct. So it's only these 3 rows of control points that we can move. Now, before we go on to really look in more detail at the shape of the scoop, let's have a look at the principle behind this. So the principle is that we don't move the first 3 rows of points, we leave those exactly where they are, and the subsequent points we can move. Now, a good way of moving these is to use the Move UVN tool, which is situated in the Transform menu. What the Move UVN tool does is move control points either in the U direction, the V direction, or the N direction, the normal direction, relative to a surface. Now, normal means locally perpendicular, so each one of these control points will move locally perpendicular to the surface. So this is an ideal tool for either adding a recess or a protrusion to an existing surface. The value that we put into this box here, into the scale box, is a real world value, and if I move a slider from the midpoint to either end of the slider here, I'll move the control points by 12 millimeters in a normal direction to the surface. So if I grab these 3 rows of points here and move them, you can see that I can start to create a dip in the surface. And very quickly, just to show the principle, I'm going to now grab the last 2 rows of points and move those downwards, and then finally the last row of points and move those downwards again. So you can see now I've started to create a surface which of course now changes from our original surface and starts to create the scoop. Now, because we haven't moved these front 3 rows of control points, when we look at this tool with zebras, you'll see that we have perfect curvature continuity between our existing surface and our new surface at this leading edge. And so the principle really is that we don't need to worry about matching this surface to our existing surface, because we know that our control points are already doing this for us. Now, the one downside here of this method is that we don't have very many control points to play with here, and there's a large area of this surface that we can't move. So what we could really do with introducing here are more rows of control points, so that we can put a little more shape into our scoop, and that we can have the scoop starting to change direction a little closer to this leading edge. So if I just undo my Move UVN operations and get back to where we were a few steps ago, I'm going to look now at introducing some control points into this surface. Now, the way that we do this is important. If we just add control points into the surface, we are going to change the shape of the surface, which of course is then going to lose our matching. Likewise, if we rebuild the surface. So what we really need to do here is to insert knots into the surface, which will add control points by implication. So I'm going to go to my Edit Tools, Control Points, and Insert Knot. I'm going to pick this surface here, and I'm going to add a knot line that's just behind this first 3 rows of points. And then I'm going to add a knot line that's just behind the what is now the 4th row of control points. And this is the result that I'll get now. I'll get my 3 control points, which are still controlling the matching, have now effectively moved much further forward. So now I can move all of these points and get more shape going on in the scoop. So again, I'm going to do something similar here. I'm going to go to Transform, Move UVN, maybe adjust this distance slightly, and I'm going to move all of these control points down. The nice thing about this tool is that, being slider based, is that you know that you can push this back and get back to your original position, and I can then change the value here, and it's a nice tool to actually interact with. So gradually going to push this shape down. Now what I've decided to do here is that I'm actually going to move these last 3 rows of control points together. So I introduce a kind of an S shape into my duct surface here. And the idea about using Move UVN here is that the surface that I've now created still has a lot in common with the top surface, so that this edge is going to be fairly common to this edge, and the fall off as it goes from left to right here is going to be fairly consistent with this surface. So again, let's take a look at the continuity here. Okay, so that front edge looks okay. Let's also take a look at this with an environment map. Okay, and that looks quite nice. Okay, so you can see that we've got a seamless transition here between our 2 surfaces. So the zebra stripes that we use here really only give us an indication of whether we have curvature continuity across our 2 surfaces. So to check with more accuracy, we can either go to Analyze, Curve, and turn on the curvature graph for both of these surfaces, or sometimes where we've got a simple proposition like it's just one single edge here, we can go to Curve and Curve from Objects, and we can extract an isocurve from both surfaces and make sure these isocurves are coincident, and then we can go to Analyze and Curve and Geometric Continuity, and we can test the continuity across those 2 curve ends. Here we'll see that Rhino is reporting that these are G2, which is curvature continuous, and we could check this at a number of positions along this edge. So once again here, technically what's doing this for us is that these 5 control points here, the middle one of which is a coincident point, are required for a G2 curvature match. If we wanted to match beyond G2, then it's the next pair of points that would be required to be involved in the match for a G3 match. But in this sort of situation here, G2 curvature continuity is fine. Let's now take a look at making the side surfaces for the duct. First of all, I'm just going to check my distance between this point and this point, and which is 36 millimeters, and I'm going to have some fairly simple linear sides to this duct, but I want to put a 10-degree taper on all 3 sides of the duct. So how I'm going to look at doing this is, first of all, to draw a line. This line I'm going to make slightly longer than my depth of the duct, so let's make this 50 millimeters long, and I'm going to put a point on the top of the line, and then I'm going to rotate this about the minus 10 degrees that we need here. Okay, and this is drawn in top view, and we're working in our world top C-plane, which is also shared here by our perspective view. The idea here is now I'm going to orient this curve onto these three edges, doing this in three separate operations, and to do this I'm going to use transform, orient, perpendicular to curve. So this is the object that I want to orient, and this is the base point, and let's start first of all with this rear edge, and you can see I can orient this onto this edge. I'll make sure the copy option in my command is turned on, and I'll snap this to one end of the rear edge. Okay, and then I'll repeat this process for the sides. So transform, orient, perpendicular to curve, object to orient, base point, and edge. Helps if you can look down the curve when you use this command, just to make sure your 10-degree angle in using this example is facing the correct way. So once more, transform, orient, perpendicular to curve, object to orient, enter, base point, and then pick the orientation curve. Okay, here I need to flip the curve, flip the orientation in X to make this taper inwards and then snap to the end of the edge. Okay, once we've achieved the orientation, we can then use a one rail sweep to create the various surfaces. So surface, sweep one rail, do the sides first. This is the rail, and this is the cross-section curve. When I use this command, I can use the simple sweep option here to give me some simplified geometry and a cleaner result. Repeat the process over here. Rail, cross-section, simple sweep, and then do this for the rear. So next we need to trim these surfaces with each other. So I'll just remove these curves, and to trim these surfaces I'm going to generate an intersection curve between the surfaces in question to start off with. You'll see that the surface edges don't actually run into each other exactly here. So the process that I'm going to use here is something like this. I'm going to go to curve, curve from objects, and intersection, generate an intersection between this side and our scoop surface. That gives me a nice intersection curve, and then just to check that this curve is running all the way along both surfaces, I'm going to go to curve and extend curve, curve on surface. Okay, and then I can trim these portions here. Can do the same on the other side. So curve, curve from object, intersection, and then curve, extend curve, curve on surface, and then I can trim, and then finally this one here as well. Okay, and then we should be able to trim these surfaces now with each other. Okay, so I can select my curves, delete the curves, select everything and join everything together, and then I want to check to see if all these edges are closed. So select the poly surface, go to my analysis tools, run show edges, make sure that only naked edges are selected in here, use a nice bright color, and you can see that all of this is closed up nicely in here. So we've now got our kind of sharp version of our scoop or duct. So now I can start to add in the blends. So first of all, I'm going to put in the two larger corner blends. So I'm going to go to Solid, Fillet Edge and Blend Edge. I'm going to use a radius here of 50 millimeters, and I'm going to pick this edge and then enter to get into the preview. And the rail type that I'm going to use here is distance between rails. So this takes a perpendicular measurement across these two edges here. Okay, and then I'm going to enter and let that build. Again, you can check this at each stage with the environment map just to make sure everything looks okay. And then now for the more difficult part. So as previous, I'm going to use the Solid Blend Edge tool for this top rail and this lower rail here. And as in the previous video, the blend will build correctly up until the point at which the edges of the blend run into each other, and then they will cross over each other. That's fine because it means that the rear part of this blend will build correctly, and the difficult part we have full manual control over. So let's build our starting blends. So Solid, Fillet Edge, Blend Edge. I'm going to choose a radius of 10 millimeters here, and I'm going to pick the entire top edge and then the entire lower edge. Enter and look at the preview that we get here. You can see that the outer edges of these rails possibly are not too wrong here, but Rhino isn't really able to trim up the interim part here. And this edge over on this side, again, the outer edges are almost probably where they need to be, but again, nothing is built in the middle here. But this is a fairly easy solution now for us to remedy manually. So I'll enter to build the blend, and what we have here is a series of surfaces that have not trimmed my sharp-sided poly surface at all. And what I need to do first of all is to split these surfaces about the point at which they intersect each other. So I'm going to go to Surface, Surface Edit Tools, and Split at IsoCurve, and I'm going to just make sure I find the correct point here, turn Shrink on here, and split this piece of the blend, and then split the upper part of the blend, again with Shrink on, at the coincident position. Now, I'm not going to throw away the front of the blend because I may need those later on, so I'll just hide these. And I'm going to do the similar sort of thing over the other side here. So Surface, Surface Edit Tools, Split at IsoCurve. Just zoom in, make sure we drop right on that intersection. Make sure we enable the Shrink option and split, and then same with this surface, and then hide these front parts. Okay, so if I just extract these portions for a moment. We can then hide this part, and let's just trim away the side surfaces now with these blend parts. So I'll run trim, I'll type in CRV so I can only pick edges, and I'll start to trim away these sides. Okay, so each time I'm picking the curve option here and just carefully trimming away these surfaces. And then now the final piece here. Okay, and then we can join these together. And we can check that these parts have joined together correctly here. That looks good. And then just take a quick look at these surfaces, make sure everything looks all right there. That looks fine. Okay, so now let's show back in the rest of the poly surface that we need here, and let's look at what we can do with this front. What we need to avoid with these fillets as they come towards this front edge is running them to a point. It's perfectly valid to have a fillet condition here where you run into a point, but in this case the geometry is not going to look quite right for us. But more important than that, because we have essentially one or two three-sided surfaces that are going to converge to a point, that's going to give us a big problem when we offset to give us our B surface. When we shell this out, it's going to give us a condition that will fail. So we want to create here a condition that not only looks good, but is also going to have enough integrity to be able to shell later on. Now, if we look at, for example, the one side here of what Rhino actually built for us, you'll see there's a fair amount of consistency about these rails here. And if we continued this edge, the front edge of the scoop here, along here, you can see that we can get two four-sided surfaces here that start with the two blend shapes and then will run off to blend into the main engine cover surface at the front. So we can actually use most of these edges that Rhino has built for us here. So let's just look at this side first of all. I'm going to just explode this surface so this part and this part are separate, and I'm going to extract an isocurve here from this main surface and snap that to this leading edge. Remember, we created this leading edge with an isocurve, so this is helpful to us now. Now let's bring in the other surfaces here as well, and you'll see we have a similar sort of situation here where the consistency of these outer edges of these fillets is actually quite good. So I should now be able to run trim and again type in the curve filter so I can only select curves and edges, and I'm going to trim the scoop surface with those edge curves. And then I'm going to duplicate these two edge curves. Curve from objects, duplicate edge. There. Okay. And now I'm going to hide these surface parts here. I won't delete them just yet in case I need to backtrack at any stage. This here can be trimmed up like so, and here this edge is a little short, so I'll extend curve on surface here, and then I can trim these parts up with each other like that. And now I should be able to trim this outer blend edge from my main surface. So this is a combination of curves and surface edges here. So I'm going to run trim, use the curve filter, and then pick these edges and these front curves. Okay, and trim this out. Having trimmed our top surface with the outer boundary curves, we can now join everything together and then select any remaining curves and delete those, and check using our edge analysis that all our edges around here are joined up correctly. And also, as we go along, it's worth checking with an environment map and also zebras as we go to make sure that we're not storing up any problems. So just want to look at the continuity here. Need to zoom into these areas to see zebras, and we may need to adjust meshes as well. When we created the corner of the main surface in the previous video, we introduced a blend curve from this point here to a midway point on this edge, and we created two four-sided surfaces and then matched them to each other. We can do something similar here, and before I do that I need to make sure that this short edge here and this short edge here is split about its midpoint. This should have been the case from when we trimmed, but just to make sure that is indeed the case, we can go to Surface and Edge Tools and Split Edge. We can pick this edge here and split it about the midpoint, rerun the tool, and do the same over here. Okay, now if we were to use the adjustable blend curve, we can either blend curves or edges, but we can't blend one of each. So because it would make more sense to use a curve for this position, what I'm actually going to do is to generate an ISO curve here and here that snap to the split edge. So I'm going to go to curve from objects, extract ISO curve, and snap to the end here and the end there. So now we can look at creating the adjustable curve blend. So let's go first of all from this curve here to the lower edge of this top rail here. So let's go to my adjustable curve blend tool, pick this curve and then this edge, and we'll blend between there. Now because of the way that the geometry is working here, we're going to see a big difference in this curve between blending from this edge and this edge. So let's repeat the adjustable curve blend and blend this front curve to this edge. And here we'll see that we generate two quite different looking curves, and probably what we want is somewhere that's between these two curves. And there is a method here that we can use that will give us that result. So I'm going to delete these two curves, and I'm going to create a curve that's an average of this edge here and this edge here. So to do that, I'm going to go to Curve and Tween Curves, and I'm going to pick this edge and this edge, move my cursor to the left edge and click, and you'll see that I can generate a curve now which is an average of those two edges. And if I go back to my adjustable curve blend here, we might see that this gives us a slightly better looking result. Now we need to look at this curve carefully and make sure, for example, that this curve isn't dipping below this scoop surface here. So let's just take a look in right view here and confirm that, and that looks okay for the moment. Now with this process there may be an element of iteration, so we may need to redo this process a few times. But for now I'll use the similar process on the second side. So tween curves and then adjustable curve blend. And take a look at this curve as well, and we'll accept that. And then we can start to build some surfaces. As previous, we're going to start by using a sweep to rail here. So rail, rail, cross section, and I'm going to match curvature at point A. And I'm going to take a look at the result that we get here. Okay, so that looks okay with the environment map, and let's have a look at this with the zebras. What we can see if we go in close to this front edge here is that we're slightly out of continuity there. And let's have a look at this point here, and again just slightly out here. So before we start to get too worried about that little lack of continuity, one thing that will help the zebras is actually joining these two surfaces together. So let's do that and see what this front edge looks like now, and you'll see that looks a lot better. So for the moment I'm going to leave the surfaces as they are. We should just actually check, I guess, that these are actually joined up properly. Okay, that's fine. And let's build in our other surface here, and let's again use a sweep to rail. So edge and edge as the two rails, and then these two edges as the two cross sections. Match curvature across both. Let's join them. Check first of all that they join up. That's okay. And now let's have a look at the analysis. Okay, so shape-wise that doesn't look too bad there. And let's take a look at the zebras. Just look right across that front edge. That looks okay. So let's take a look at doing something similar on the other side. So surface, sweep to rails, first rail, second rail, cross section, and let's match for curvature on that top edge. Take a look at this shape that we get here. Okay, that looks okay. and take a look at the front edge with the zebras. Just pull right into that edge. It's not too bad. And let's build another sweep in here. So I want the edge here, not the curve. Edge here, edge and edge. Match for curvature. Cross both of the rails. Let's join. Check the join. And repeat the work with the environment map. Okay, so we should see that we should get a pretty good result here. Now, in some circumstances, you may find that as we get towards the front here, that this edge becomes slightly problematic. So you might need to consider building a four-sided surface here, matching to three sides, splitting the edge of that surface, and then, in other words, giving a little more room where this is one single surface. Might help the shape of the front of the blend in some instances. So once we have achieved this, we can show in our other parts of the geometry and join back together. Once we've joined the surfaces together, we just want to make sure that our result is a closed polysurface, and also we can just run the environment map again just to make sure that we're happy with the various blends that we've created. Now it's time to look at adding any additional detail and then to mirror the other half of the engine cover. So I'm going to extract this center planar surface here and delete that, and then just run the mirror tool. Here the copy option fairly obviously is on, and I'm just going to hit the y-axis option here to mirror about a line of symmetry. I can then join the two halves together and take a look at the result again with an environment map. Okay, so for this center blend here, I could use the solid blend edge tool, but there's possibly an easier way to do this. I just want to check the distance across the perpendicular here, 19.999, so it looks as though I used a 20mm blend across this edge, and I'm going to go for something similar across the middle here. Actually, I'll probably use something slightly sharper across the middle. And let's look at a pretty easy way that we can do this. Going to take a line here with the both sides option, start the line at 0 and pull the line along the center of our engine cover here. And then I'm going to offset this curve with the both sides option on by a distance of 8mm. So I'll have a 16mm overall blend across the center. And then I'm going to pick the two outside lines here and just trim away my engine cover. So we've now got a gap here between the two halves of our engine cover, and I'm going to use the blend surface tool to create a blend across these two front surfaces here and across the two top surfaces. And then this area here I'm going to blend separately because I really need to control the shape of this blend correctly across here. And then for the underside and the back, these are just fairly simple planar surfaces. Now I want to make sure that I've got enough shape to the blend here, so I don't want this blend to be too flat. So I'm going to run the blend surface tool here, first of all across this edge here, and I'm going to lock the sliders, and I'm just going to push up the blend a bit here, and just make a note of this blend factor that I'm using here. And let's just have a look at this with the environment map. I want to make sure that I can see a reasonably sharp blend across this center. Okay, that looks okay. And then I'm going to use a blend with the same factor on the front edge. So once again, lock the sliders and use the same factor here. And then also take a look at this. Okay, that looks okay. Now you can see that this blend here is built slightly short, and as a result what I'm going to do is extend all of the edges of the blends just slightly here, and then I'm going to trim them off. So let's extend this by a couple of millimeters, and this one, and this back edge here. First of all, let's do the easy parts here. Let's just trim with a line this piece of blend here, and do the same at the front. Okay, and then to get the shape of this little nose piece right here, I'm just going to use a technique that we've used before in this exercise. I'm going to use adjustable curve blend across here with a curvature continuous blend, and do the same here. And then I'm going to take this and pull it back onto the blend surface, and then trim away the blend with it, and then likewise do the same here. Okay, if we blended this all in one go, so we blended this, and this part here, then we wouldn't get this curved shape going across here. I think this is going to be important to explain the shape here when we see the final result. So now we need to look at just creating the surface that's going to fill in this little nose area here. Now I could use a two-rail sweep here, but the issue will be in actually getting this edge and this edge, which are the cross-section edges, to actually join into a watertight condition. So I'm going to look at using a network surface here. Now the disadvantage of a network surface is that it's going to be slightly complex, but because my geometry is reasonably good here and my boundary shapes all have a lot of similarity to each other, then I think that the results should be okay here. So I'm going to use curve network, pick the 4 boundary curves or edges, match for curvature on each edge, and the important issue here is to make sure that this value here in the tolerance is the same as your absolute modeling tolerance that you're working to. So here we're using the default small objects millimeters tolerance of 0.001 of a millimeter, and that's the value that I need to set in here. If I slacken this value off, then my surface will be less complicated, but there's less chances that my edges will actually join into a watertight condition. So I'll preview that surface and I'll OK this. I'll join this together, and now we can take a look at what this looks like. Okay, so that looks okay. And let's take a look at this with the zebra stripes. Let's actually first take a look, make sure that this is joined up into a watertight condition. Yep, that's okay. And let's take a look at the zebras across the edges here. Okay, so that's pretty good. Okay, I can't see any disruption along these edges here. So all we need to do now is to create our planar surfaces to close off the volume. So just draw a little line across here and then use surface from planar curves here. Join this together, and I can just cap to finish off the lower part. Okay, so we've got a closed poly surface now. So just a few things now that we need to do to get the geometry ready for SolidWorks. First thing is that any coplanar surfaces like this are possible issues for SolidWorks, so we can clean these up very easily. Pick the geometry, go to our Solid tools, and right click on this tool here, and this is Merge All Coplanar Faces. And any coplanar faces here will be merged. Okay, so you can see that this face now is one face, as is this one here. The other tool that I need to run here is Shrink Trimmed Surface. And I can run this on a poly surface here, and it will shrink the individual surfaces. So Surface, Surface Edit Tools, and Shrink Trimmed Surface. Okay, and here it's going to shrink 75 surfaces, and 44 are already shrunk. These solid modelers will work much better with trimmed surfaces. The disadvantage of shrinking is that if you need to untrim and rework any of the blends, then you may have reduced the size of your base untrimmed surface by too much to do this. So you would generally do this on a copy of the geometry. So one last thing that we should do now is just to pick our geometry and run check, just to make sure our poly surface doesn't contain any bad surfaces, and that's all fine. And so we're now pretty much ready to move downstream, in this case to SolidWorks. So I hope you found this video useful, and thanks for watching.